So, yes, so to me, there is only a couple of important ideas I really want to send across, and they have to do with the interface between the work in artificial intelligence and the work in the social sciences. And it's turning out to be quite a crucial, important, strategic piece of place to work. And I would like to make some explain why and make some considerations. It does shape, I think, our interactions with the scholars in law and economics and political science and social science, and I'm discovering how important it is. And the reason why it's important is surprisingly a technical reason. So here we go. Hear me out. And by the way, I will not patronize you with the long list of. I have my slides in front of me, but you surely know by now what are the challenges that we are trying to face. There is a proposal for a law in the European Commission and Parliament being discussed. We know what we are trying to understand here. So how do we build intelligent machines, though? Because that is the key to the regulation and to the safety measures we need to develop. If we don't understand what we are talking about, we might end up solving the wrong problems. So here is my little story, which I think is, I hope you haven't heard from me before, but I remember when I was a student, and I was a student in Trieste, but my thesis was written in Milano, and the supervisor was at the Politecnico. And I remember very well the way they worked in classical AI group, symbolic AI group that was happening at Milano in the middle of the 90s, early 90s. And the idea was that if you went to the professor there to ask for a thesis on recognizing people, recognizing the face of people from images, which actually did come up as a consideration back then when I was doing my own work on a different topic. Some people were discussing that. Well, the natural question any sensible professor of the early 90s would tell you is, if you want to recognize a face by AI, you need to have a good model of what a face looks like for each person. There is something to do with anatomy, maybe with some morphology. There are a series of things you can measure, maybe eyes, distances. There can be some biometrics you can do. It was all about understanding a theory and then implementing it is the second stage. And of course, you can imagine how difficult it would be for some engineer to study all of this material in anatomy and so on. And that was done across the board in every domain back then. Language, translation, speech recognition. In that mindset, it was all a matter of understanding language and translation and then implementing it. A student came to me a few years ago here in Bristol with a very similar question. He proposed to recognize men from women by the image of the face. But that was 2010 or 13. And my first question was not about study the anatomy of a face and so on. The question was, do you have enough data? We need 5 million images. And so probably he said, no problem, I can get 5 images, I come back next week. He made a scraper, he went online, he scraped, I think he was using for privacy reasons, just actors in movies, which was done for a specific reason that these people have a different expectation on the privacy of the image, and scraped off a few million images of actors in movies and their gender. He came back, and I said, well, now let's just plug in a big neural network and train it to classify the two categories. And we had a very large computer, which we had to work to find, and so then we trained the network. So in this picture, actually, the software was for free. The neural network was available online, untrained. The data had to be collected with some creativity, but was already in digital form online, in this case, movie actors. And the hardware was difficult for us. We wanted a large machine with 8 GPUs, which we found. And this is a very different world than the world I knew 20 years before, when the problem was understanding, modeling, studying. I think if somebody had told a student in the 90s, find 5 million images of faces, you would have had to get a camera and photograph 5 million people. If the cost had been €1 per photo, you would have to spend 5 million euros just to begin. Do you understand? So the world has changed profoundly. We solve the same questions in a very different way, and we do it by exploiting data and machine learning. And because we don't want to pay for our data, we take one shortcut. We just harvest the data that is already available out there in the wild. That is the expression people use, data from the wild. We scrape it, we use it. In our case, we didn't want to keep it in the machine for copyright reasons, so we just showed the images to the neural network and then didn't save it. That was our choice, but you can do it either way. So making the software, not a big deal. Getting the data, not a tragedy if you're using data from the wild. The problem was the hardware, but even the hardware is becoming commoditized. You can go on Amazon Cloud and do it for very cheap. That is what we call artificial intelligence. If you want to build a spec, you will train a similar system on a large corpus of text, maybe a newspaper. It will learn which are the most frequent words and phrases and which ones can be recommended or flagged as suspiciously, potentially wrong. From the data to the decisions. No need to introduce linguistics and grammar. Which reminds me of a famous sentence that the famous Friedrich Jelinek used to say at IBM. I know at some point there will be Francesca from IBM, I don't know if she's there, but Jelinek was working on this many years ago, and he had a slogan that was, every time I fire a linguist, my performance goes up. It was quite a challenge, wasn't it, to one style of AI? Well, sometimes in artificial intelligence, we needed to know people preferences. And again, you could design a system to approach people and ask them, do you prefer this movie or that movie? Which kind of movie would you like me to show you tomorrow? But we don't do that. There is a cost to that. We decided that if you click on something, then you must have liked it. And we get this click to mean something else, to mean that you approve of it, you want more. We invented many ways to gather many types of data from the wild for free. When the data isn't available, we use proxies, replacements. And then we teach to the machine the meaning of words and other things from statistical patterns the machines can find in this data. We use those tools later to do things, screen CVs and other things. So that is the reason why we have a challenge today. The way we do AI is done in this way, which is beautiful. It's elegant for me. I've done statistical learning theory all my life. I can't believe how well it's working. but we have this challenge that we are discovering some interesting side effects. For example, side effect number one. If I use as a proxy for relevance the fact that you clicked on a video, I'm no longer recommending you something that matters to you. I am learning to recommend to you the kind of stuff that you get to click on. Sounds similar. That's a place for philosophers. But actually, it turns out the kind of stuff you're going to click on doesn't have to be the stuff you want. It could be the kind of stuff you can't resist. My learning algorithm, the recommender engine, might just slowly learn the kind of stuff that you can't resist. It finds your weaknesses, and then it exploits them to make you click more. Nobody meant it. It's a side effect of using that proxy instead of relevance. If I decide to represent the meaning of a word by the statistics of the words that surround it, as we do all the time, well, it turns out I have to train this statistical system on data. And people were appalled when they discovered that in this new representation, beautiful, elegant representation of the word meaning through the statistical distribution of the words surrounding it, called the word embedding, beautiful technology. Well, people were surprised when it was discovered that in this representation, the word pilot is close to a man and flight attendant to a woman. Doctor is a man, nurse is a woman, and so on. CEO is a man, for example. Secretary is a woman. These gender qualities are not in the word, they are in the usage people make of this word in today's society. So if we learn the meaning of words from their usage on the newspapers, we are going to absorb the grammar, the syntax, the semantics, and this pragmatical information that is there. So what does this mean? That maybe we took some shortcuts a little bit too fast. Maybe the hope that we can get something for free was a bit optimistic. And the idea that we don't have to understand a phenomenon before we replicate it in a machine, maybe it was also a bit of an optimistic idea. So if you are a software engineer, all you want is a task, a piece of data, a piece of code, and people tell you that's the performance you optimize. Maximize the click-through of YouTube. Minimize the number of spelling mistakes in spell check. That is your work. You need to trust the data is clean and you guarantee statistically the optimal performance you can get out of this data. What you don't want to hear is, well, how do you know the process behind this data? Well, it turns out the process generating the data we use, the data we find in the wild, that process is a social process. There are people with their biases and their cultures, their traditions, generating language that we use to teach our machine how to speak. If these people have commitments and biases and inclinations, they may leak into the machine, and the programmer wouldn't know. If I use movie stars, as we did, to distinguish men from women, what's going to happen? Well, it works. We are very pleased to have 97.5% performance. It's good for us to test our machine. But if you want to deploy this in society, remember, not everybody is a movie star. Not every age is represented. Not every gender, not every race is equally represented in and not every physical shape. The machine will become really good at recognizing whatever is the beauty standard of Hollywood, and that will be its normal. And then there will be deviations from normality. Every single choice you make without realizing has an interesting implication. And understanding this means working in this difficult interface between the social sciences, which produce the training data, the computational sciences, which exploit it, and then back on the other side to society, because we are going to deploy this in society. And we close a feedback loop. A recommender system learns from people, but then it acts on people. Two interfaces. That means that we can create the famous filter bubbles. Certain people are recommended increasingly large amounts of the same content because they click on it. And they click on it because they see it proposed and promoted. And by clicking, they even increase the probability of seeing it tomorrow. So the filter bubble in its own right is called a positive feedback loop in control theory. Shapes the kind of stuff you see. And then there is a secondary effect that we know from the social sciences. People are shaped by what they read. If you are a media scholar, you will know the expression cultivation theory. The public opinion of readers of one newspaper will be cultivated and shaped by the reality of the newspaper. So the interaction goes both ways. It's fascinating. It is alarming because we don't have another way to do artificial intelligence. Our intelligent agents need data. And the way to get data is to position them at the center of this medium, of this data infrastructure that mediates everything we do. So most spell checkers, vision systems, speech recognition systems, recommender systems, they need to interact with us in order for them to become good and useful. And their business model is by the way, requires us as well. So they are in the center of our infrastructure. They have to look at us. They have to learn from us. They have to a little bit manipulate us because the revenue model is advertising nearly all the time. Not all the time, but often. So it's a conversation that must happen. It's happening already. And we need to have the way to understand it. The social scientist and the politician must understand how we do things. The statistician needs to understand how the data is generated. Otherwise, we are going to barking up the wrong tree. We are going to hear people developing the ethical chip that will allow the machine to make ethical decisions based on some ethical framework. But the machine doesn't make decisions in this way. Very often, the recommender engine just has a statistical reflex based on data. So you wouldn't know where to put this chip. And this is, I think, let me see how much time I have before I move on to the next topic. I have 10 minutes. So this is half of the story. I think it must be said. Now we should be optimistic. Once we know what's going on, yes, we need to understand it, regulate it. To some extent, once you know what you want to fix, it is possible to fix it. My little group was able to develop systems to remove the gender bias from word embeddings. It wasn't so difficult. We invented another system to remove much more complicated biases from image recognition neural network. It takes more work. The performance of the network is a bit less, but you know it is not going to use forbidden information. Forbidden or taboo information is information we want the agent to never know. And that's a tricky one. So, for example, you are classifying curriculum vitae of people. You really don't want the machine to use any information about gender and race because you want the best employee and you want to follow the laws of your order. However, there are words in the CV that implicitly, indirectly give up this information. If your hobby is rugby or if it is ballet, you might have different gender probabilities and so on. So the machine could learn by mistake that in the past, the best programmers we had in the engineering company preferred, I don't know, rugby to ballet, and in the future it could look for more of the same, and that could be an interesting bias that leaks into the system. So we built a system that actually is guaranteed to not be even internally representing any illegal information. That's useful because we know that there are not too many dimensions. There are a few dozen things that the machine cannot know. You know, the machine, when making certain decisions, the decisions about health, opportunities, financing, education, jobs, accommodation, in those domains, the machine cannot use gender, race, religion, political inclination, age. You know. The combinations are many, but not too many, and you can just make sure that your machine just doesn't even know anything about it. The machine will be weaker. And there is a trade-off to be understood. How much worse a performance should we accept in return for that level of extreme agnosticism? Or can there be other solutions? And there are people working on easier solutions, like double checking some type of equality. But of course, software engineer is not trained to distinguish between equal opportunities or equal outcomes. That are fundamentally different ideas. They will implement a piece of code without realizing they take sides in a very ancient debate in political science. What kind of equality do we want? You know, if you're screening, that's quite important. So what matters to me is to become aware that it's part of the professional picture for an AI designer to think about the data, the process generating it, and the effects of deploying a tool. And that is becoming these days increasingly the case, but not nearly as much as we need. At the same time, we must educate the social scientists to think in these terms. Now, we do have an Artificial Intelligence Act in the works. I know the first presentation today was about it, and I so much regret missing it. But at some point, we need to come to terms with that famous third level of high-risk applications that needs to be understood, because that is where the problems will be. That is what I really want to get right. What is a high-risk application in AI? I am afraid that we may need to be a little bit more demanding. And a high-risk application, of course, is one that can break those European values that I just mentioned, equality in certain conditions. But there are other things. We have a right to our autonomy, for example. I worry a lot about my right to make an autonomous decision. This has got nothing to do with biases and fairness and equality, and that's the domain. Autonomy is the right to not be manipulated, for example. So if somebody can establish the risk of behavioral addiction in some situations, that needs to show in the laws, and so on. So all of this, incredibly enough, is not computer science, if you notice. We can talk for hours about artificial intelligence without talking about a single algorithm, because these are bigger questions about the sources and the data that we use to train the algorithms. But then, at some point, we must mention the algorithms, because the way we build algorithms based on statistical relations is fundamentally different from the way we think as humans. So there is no way we are going to understand why a machine made a decision. In the GDPR, there used to be, there is some reference to making our machine decisions understandable or explainable. It's ambiguous, it's unclear, but it's there. In the Artificial Intelligence Act, I don't quite see that word. I see other expressions. Are we still entitled to an explanation or not? We need to work on that before it's complete. Because the idea that my son uploads his CV on some online site, I can't understand. And then he candidly waits by the phone for weeks and the phone never rings. And he will never know why the employers never even got to see his CV. Was it a keyword mismatch? Was something to do with some of his hobbies? Was it something else? Did he write enough words? I even hear that the admission essay, when you apply for a college, I hope it isn't true, but I hear about automatic scoring. Can you believe it that it's true? People pour in their heart out with all their hopes to study physics or something, and in the essay, and then there is a software decided. I hope it's never going to happen. So we need to understand how the software works, so we can regulate it, we can assess it, we can monitor its performance, but we need also to understand how the data is generated. That is an interesting place to be. I am working in that place. I hope people will be working in this place for a long time. And that's my time. So thank you for listening.